Hey guys, thanks for watching this video on factoring. In this video, you're going to find everything you need to know to master factoring for the spiral review test. All right, let's get started. What is factoring? Factoring is rewriting a sum as a product. Sum uses addition, product uses multiplication. So we might have something like this, 1 plus 1 plus 1 plus 1 plus 1. In total, we've got 8. And we can rewrite it as a product of 2 times 4. In other words, 8 can be rewritten as 2 and 4. 2 and 4 are the factors of 8. All right, now we kick it up a notch here in Math 2, and we're not just talking about numbers, we're using quadratics. So over here our expression is x squared, this piece, and 1, 2, 3 x's, and 2 singletons. And we're going to rewrite this as a product. We want to use multiplication. Well, it would look something like this. We look at the outside, we've got x and a plus 1. Here we've got an x and a plus 2. And so we can rewrite this as x plus 1 times x plus 2. And notice we went from addition to multiplication. This process from going from a sum to a product is the process we call factoring, all right? Now you might notice factoring makes rectangles, and it rewrites it as a length times the width. We did that here, 2 times 4, and here x plus 1 times x plus 2. So if we can make rectangles, then we can factor. All right, so how do we do that? How do we get from here to here? Because we're not going to have algebra tiles available. We don't want to do this detailed picture every time. But we should notice is there are 4 natural sections when we do an area model like this. The x squareds go in the top corner, the x's go in either corner here, and then the singletons go in the bottom right-hand corner. So when we have something like this, an expression like we had x squared plus 3x plus 2, and we know we need to write it as a length times a width, we use 2 tools. We use an area model and we use a diamond problem. And they set up pretty much the same way every time. We take our x squared terms, and those are going to fit here. And then we know our singletons are going to go in this corner too. So of our pieces, we know we've used the x squared and we've used the 2, but where do the 3x go? There's 2 spots, but only 1 term. Well, to help figure out how to split this 3x up, we use a diamond problem, right? And that diamond problem, we put our 2x squared on the top, and we put the 3x on the bottom. What we found is this pattern where whatever these multiply to be, these multiply to be, and that's called Casey's pattern. All right, so if these multiply to be 2x squared, then what do these multiply? Okay, these also multiply to be 2x squared, but we only have 3 x's to work with. So this diamond problem works like this. We need 2 numbers that multiply to be 2x squared and 2 numbers that add to be 3x. And it's pretty obvious in this case, 2x times 1x. 2x times 1x, 2x squared, 2x plus 1x gives us 3x. So we fill those in our area model. 1x here, 2x here, and now we've used all of our pieces. Okay, well, now it's just a matter of filling in the outside edge. Well, this piece right here is x times x. And x times x is x squared. And x times 1 gives me 1x. And x times 2 gives me 2x. And 2 times 1 is 2. And everything works out. And here we go. X plus 1, that's my length. And x plus 2, that's my width. Now, I don't have a sign in front of the 1, but we know this is a positive 1 by default. We'd know it was minus 1 if there was a negative in front. All right, so this in a nutshell is how we factor. All right, now let me give you a more complicated example because we know math gets a little bit harder. All right, so here I've got a bunch of pieces, 4x squared. I've got 6 negative x's and then negative 18. And if I arrange them in a nice, neat rectangle, it looks like this, which is fantastic. But how do we get from here to here? How do I rewrite this as a product? Well, again, we use our two tools. We start with an area model. I take all 4 of my x squareds and I put them right here in this corner. And then I take all my singletons. There's 18 of them and they're all negative. They go here. Okay, well, how do I split up my 6x's? Well, I don't know how many go here and how many go here. So we use our area model. Excuse me, our diamond problem. So the diamond problem. Well, if these multiply to be, oh my gosh, 4 times negative 18, that's negative 72x squared. And I only have negative 6x to work with. I got to find 2 numbers that multiply to this but add to this. And that's a hard thing to do. Now, I put together this list, and if you're not so great at like recalling your multiplication times tables, make this list. Start at 1. 1 times 72, 2 times 36, 3 times 24, 4 times 18. And if you don't know 4 times 8, use a calculator. How many times does 4 go into 72? Hey, 72 divided by 4, 72 divided by 5, 72 divided by 6, 72 divided by 7, 72 divided by 8. And you can put together this whole list. And what are we looking for? We're looking for 2 numbers that add or subtract to be negative 6. And so when I look down this list, what adds or subtracts to be negative 6? I notice that I've got a 6 here and a 12 here, and if I subtract those, I end up with negative 6. So I'm going to go with 6x and 12x, but one of these has to be negative. I have more negatives, so I want the bigger number negative. Okay, so I fill this in. If these multiplied to be negative 72, then these multiply to be negative 72. I've got negative 12x and positive 6x. And now I just fill in the outside. Well, the outside edge right here. 4x squared. I could go 2x and 2x, or I could go 4 and 1. In this case, it actually does not matter. I'm going to go with 2x and 2x. All right, and 2 times what is negative 12? All right, 2 times negative 6. And 2x times what gives me 6x? That would be 3. And just to double check, 3 times negative 6 is negative 18. Works out. All right, so we've got our length and our width. 2x minus 6. And on this edge, 2x plus 3. Voila, we went from a sum to a product. And if you can do this one, you can do any of these. Let me give you one more example here, because that last problem we could have done a lot easier. There is an easier way if we look for a common factor. So right off the bat, I should notice that 4 and 6 and negative 18 all have something in common. They all have a factor of 2. So I can rewrite this problem by taking out my common factor and reducing the remaining product. So I'm going to use my area model, but I'm only going to factor what's in here. Notice how much simpler this makes things. I've got 2x squared and negative 9. Check and check. Okay, so I got to figure out how to split up my negative 3x. Well, if these multiply to be negative 18x squared, then these multiply to be negative 18x squared. But I only have negative 3x to work with. And notice how working with products of negative 18 is going to be much simpler, right? My list is so much smaller. 1 times 18, 2 times 9, 3 times 6, that's it, right? So I'm looking for which of these adds to be negative 3 or subtracts to be, 3 and 6. So I go with 3x and 6x, and one of them's got to be negative. I'm going to make the bigger number negative, and I fill it in, 3x and negative 6x. And last, I just got to put together my product, my outside edge. So what multiplies to be 2x? Well, it's got to be 2 and 1. I want to put the 2x here because the 2x goes into the negative 6x, negative 3 times, and the x times 3 right here. X times 3 is 3x. 2x times negative 3 is negative 6x. And negative 3 times 3 is negative 9. We've got our length. 2x plus 3, and our width, x minus 3, and don't forget our original common factor of 2, and he stays out front, and we've gone from a sum to a product. All right, looking for a common factor first is going to make things way easier. All right, I hope you've enjoyed this tutorial on how to factor. Good luck studying.